this is a lesson for the Module 1 summative assessment. There are no fancy notes available right now, and there will be another video that I will post later with the fancy notes and all this instruction again that goes along with the fancy notes. But this is a great one for today's live lesson. So the things that you need to know are these two standards. So G.GPE.5, G.GPE stands geometric properties of equations, and it's the fifth one of those standards. And NCN stands for numbers. Complex number 6, which has to do with, specifically for our stuff, is calculating the midpoint. So let's go over the stuff for GPE 5. I'm going to do problems similar to the ones that are here. And I think actually I am going to do this. I'm going to see if I can. Oh, nope, I can't. I was going to try to do it on my iPad, but that is not going to work. Okay. Okay. The best thing to do here. So you'll need to know for GPE 5, for the first question on the whole quiz, is if slopes are equal, if two lines have slopes, if two lines have equal slopes, they are either parallel or the same line. I'm going to make this, is that going to work? Or, so that didn't want to go. Or, go like this, they're the same line. Or they are the same line. And so a reminder, so let me just put this reminder in a different thing. Reminder. Remember to simplify slopes. So you can compare them. So for example, if I said that, if I said I had one line, if I said that M has a slope of, I'm going to do 15 thirds. No, I'm going to change that, 1/3. And N has a slope of, I'm going to do 12. No, I can't do 12 because that's too big of a number for me to type. 9/27. I went down to the other line after all that. 9 has, I should put has slope. That'll be 9/27. Oh no, let me type in there again. Oh, I didn't let me type the 7. Hold on, let me try it again. Is it going to go in the right spot? Let me find out. 27. It's going to be higher. Okay, so one of them has a slope of 1/3. Another one has a slope of 9/27. What do you know about, what do we know about line M and line M? Are they parallel? Are they going to intersect? Are they going to have proportional slopes? Or can you just not determine anything about them? So here are your options. And so then I'm going to ask the question. I'll type the question here. Make it smaller. So what can be determined? Jackson says they're parallel. That's a good conclusion. So what can be, oh, you know what? I just realized I'm going to have to just backspace this and make this thing a whole lot bigger, because if I don't make it bigger, I won't be able to type anything. Okay. What can be determined about distinct lines M and N? So our options were parallel, intersect, proportional slopes, nothing. These are our options. Okay. And so if you took these 1/3 and the other one, 1/3 and 9. So took these two things, 1/3 and 9 over 27. In fact, if 9 over 27, if we divided the top and the bottom by 9, in other words, simplified the fraction, we would still get 1/3. And so since they both have the same slope, which we put right here, if they have the same slopes, it's one of those two, the answer has to be they are parallel. If the slopes were different, maybe if the top one was 1/3 and the bottom one was negative 1/3, then we know that they would have to intersect. So same slope means they're parallel. If they're different slopes, no matter anything else about the thing, if they have different slopes, they are going to intersect. And that's it. That. Okay, next question. Has to do with, and so I think what we're going to do for today is focus on GPE 5, and then we'll do the other one another time. GPE and NC are both Unit 1. Yes, they all come from Module 1 Summative Assessment. So there are two standards on that assessment. The first few questions, I don't remember, let me see how many questions. So 1, 2, 3, 4, 5, 6, 7. The first 7 questions have to do with GPE 5. And then the other ones have to do with the midpoint one, which is that GPE 6. So there are 11 questions on this. Is that correct? Yep, 11 questions, and 7 of them are from GPE 5, and the other 4 are from NCN 6. So, okay. All right. So the rest of the stuff, it's all algebra stuff that I don't know if you've done. I don't think we did this in Algebra 2. But it is for sure stuff that you did in Algebra 1. So it's kind of remembering what you did in Algebra 1. And if you're like most students, then you're like, oh, snap, I don't remember how to do that. And so it's okay. I'll share with you. So it'll give you something like this. It'll give you the point. So we want a line. We want a line parallel to, and then I'm going to come up with an equation, y equals, let's say, negative 3x plus 4. That goes through the point. Somebody tell me a point. What point should we say? Any point. It can be anything. Just make up a point. X, Y. What do you want to say? Nobody's typing anything. I'm going to make up my own. Okay. So because it doesn't matter. I'm going to say it goes through the point 0. Oh, does this have a 0? No, it has a number. So let's do negative 4, 7. Okay. We want a line parallel to that goes through that point. So parallel. What did we learn in the last thing? What does parallel mean? What do those slopes have to be? What do we know about the slopes of parallel lines? What do we know about slopes of parallel lines? Parallel lines have what?
Like
the same times table?
I don't know the way to say it.
That's one way to put it. The same slope. Can I do that?
Yeah, but you can also like divide down.
Same slope. So the parallel lines have the same slope. And then also next thing that we need to remember is we have the equation y equals mx plus b, where m is equal to the slope and b is equal to y-intercept. Oops, I need to have the normal y-intercept. So we want it to have the same slope. So we know for sure our equation needs to, the new one that we're going to come up with needs to have a slope of -3. So we can start our whole thing like this. There are a couple ways of doing this. The way that the book or that the thing shows is one way. This way that I'm going to show you is another one. It doesn't matter which one you do, but for sure I know that my next line is going to have an equals -3. And then so that's the only thing I know. I'm going to put plus b because now I have to find out what the b needs to be so that I can recognize stuff. So it's going to be y. Oops, it's supposed to be y, so you write it kind of backwards. Okay, y equals 3x plus b, negative 3x plus b. Now we can plug this in for the x and this in for the y, and then solve for b, and then that's what it has to be. So we go like this. We're going to have 7, I'm writing with my finger, I apologize, equals negative 3 multiplied by negative 4, because that's what my x was, and then plus b. So plus b. Now we need to solve for b. So in order to do that, this is algebra stuff. Do you guys remember doing this algebra stuff? Does it look familiar? You may have even done it in pre-algebra, and by pre-algebra, I might also mean like math 8. So negative 3 multiplied by negative 4 is positive 12 plus b. And we didn't do anything with 7 on that other side, so I'm just going to write 7. And I just want to solve for b, so I could subtract 12 from both sides. And when I subtract 12 from both sides, I'm going to get a negative. And I can tell because I have 7 positives and then 12 negatives. That's more of them. So it'd be negative 5 is equal to b. That's a really sad looking 5. But, you know, writing with your finger, that's what it does. Do you guys have permission to write with your finger? You should try it. Then we have y is equal to, and we already know our slope had to be negative 3, so we're going to keep it. And now we put the x back in, but now we know what b is, and so it'd be subtract 5. And that is how you do that. So there's a problem just like this that you'd have to do on the summative assessment. I did get a text. I didn't read the last one, Jackson. I'm going to finish doing this, and then I'll read it if that's okay, so we can keep on moving. All right, next one, you'll have something like this, and I'm going to see if I can type it because that's what I want to do. Okay, so you'll have an equation that looks like this. We want one that is, we want parallel to, and then they'll have some equation like y plus 2 equals negative 2 multiplied by x subtract 3 goes through the point 7 and negative 8. Okay, so we want a line, and so this is a different form of the equation, and this form that it's in, so I'm going to type it up just so that you know what that's called. This form of a line, is what I should say, is called the point slope form, because we technically right here, like that was supposed to be drawing and it didn't work out. Okay, so technically this right here and that right there is from a point, and then that right here, this is the slope. The letter that we used for slope on the last one was the M. And so if it's parallel, we want it with the same M. But then this is the clever thing. You don't even have to do anything fancy with this to begin with. You're just going to use this as the new X that they put right here with the X. And this is the new Y that they put right there with the Y. And then you're just going to like make it look, because all the answers are in slope intercept, that y equals mx plus b form. So that's all you'll have to do. So this is all you have to do. You're just going to do y, and it'll be subtract 8 because it's just the thing that's right there. Y subtract 8 is equal to negative 2 because we know it has to have the same slope. And then this is the weird thing. It's going to be x, but instead of regular 7, it's going to be the opposite of 7. So it's going to be subtract 7 right there. And then we just need to make it look like slope-intercept form. So we're going to distribute. So the next thing we're going to do is distribute that negative 2 So what would you have? What can you guys type it? What is negative 2 multiplied by x subtract 7? Negative 2 multiplied by x, and then negative 2 multiplied by subtract 7. We're distributing that or multiplying that. No? Okay, so negative 2 times by x is literally just negative 2x. And then negative 2 times negative 7 is positive 14. Writing with my finger takes such a long time. I'm sorry that I have to do that. That's what my options are. And so then we just have y subtract 8 equals that. And we don't want the y on that side, so it looks like slope-intercept form. That means the y equals mx plus b. So we just add 8 and add 8. And then you'll have the answer. So y is equal to negative 2x. And then 14 plus 8 is 22 plus 22. Oops. Doesn't look like a very good 22, but you know, that's what we did. Okay, quick comment on this before we do anything else. Let's just say that my slope was instead 1/2. Just so you know, 1/2 x is the same thing, and you need to know this. This is a nudge, nudge, wink, wink. Like I'm giving you a big hint. Is the same thing as saying x over 2. They mean the exact same thing, because half of x is the same thing as x divided by 2, right? So I just wanted to remind you of that little statement. All right. Next thing that you know, slide 4, and I'll type this up. Next thing you need to know for these things, and so here's the big idea, the big concept, is that perpendicular lines have slopes that are, and then two main things with it. They are opposites. So if one of them is positive, the other one is negative. And the other part is reciprocals, which I say reflipricals because I'm nerdy and because it helps me remember that, like, you would flip it. So if I had one equation, so just as an example of this, if I wanted to find the line of something that was perpendicular, if I know that one equation was y is equal to 3x, ooh, that's a sad 3, but you know, go with it. We don't judge here, right? So 3x. Then the opposite reciprocal of 3 is what? What is the opposite reciprocal of 3? And just as a reminder, 3 is the same thing as 3 over 1. So if I flipped 3 over 1, what would I get? And then make it negative. And I'm going to use some nice math symbols because I'm writing with my finger and it makes it easier. An upside down capital T with a little square in the corner, that's the symbol for perpendicular. So y is equal to 3x is perpendicular to y is equal to what? What is the opposite reciprocal of 3? Try it out. Make a guess. Type it in. What is the opposite reciprocal of 3? So opposite. So instead of positive, negative. And then reciprocal means like you take that 3 over 1 and you flip it so 1 is on top. That's the reciprocal. So the opposite of that then is negative 1/3 x. Okay, so then yeah, if they are opposite reciprocals of each other, then they are perpendicular. So I'm going to type some more in, and I want you guys to tell me if these are opposite reciprocals. Let me change the color because I want to. So if I had that y, oops, that didn't work out. I had y was equal to 6/5 x plus 130. And the other one was y is equal to 5/6 x subtract 20. Are those parallel, perpendicular, or neither? So the question is parallel, perpendicular, or neither. What are those? Oh, you can't see neither. So which one is it? Parallel, perpendicular, and I'm going to try typing or neither again. Or neither. That was a little bit better. Which one would you say? Are these lines parallel, perpendicular, or neither? Do they have the same slope? Do they have opposite reciprocal slopes, or neither one? Okay, so you're looking to see, so parallel, remember that parallel means they have the same slope. So let me come in here and try really hard to write the word same. So actually, I'm going to put equal. They have equal slopes. Perpendicular has the opposite reciprocals, like both of those. And then neither means neither one of those. So 5/6 and 6/5. Are those equal, first of all? What would you say? 5/6 and 6/5. Are those equal numbers? No. So we're going to for sure say they're not parallel, different slopes. Okay. So they're not parallel because they have different slopes. Are they opposite of each other? Is one of them positive and one of them negative? So not opposites. Not, I'm going to put positive and negative. And basically, you can stop right there because if they're not opposites, they're for sure not going to be perpendicular because they have to be opposites. They have to have both. And I should put up here both. Type it in. Both. You have to have both opposite and reciprocals. So the answer for this one is neither. So they are neither opposite nor reciprocals. So the answer for this one is neither. Okay, I'm going to give two more things, and I want you to tell me opposite, parallel, perpendicular, or neither. I'm going to type in a new one. Let's do another color. I don't know if you can see this one. Tell me if you can see it. So we have y is equal to negative 2/5 x plus 17. And the other one is going to be y equals 5/2 x subtract 2. Okay. Parallel, perpendicular, or neither? Parallel, perpendicular, or neither? What are these? Perpendicular. Okay. Jackson says perpendicular. Does anybody, who else agrees? If you agree, say agree or yes, or I don't know, something. Type a puppy if you can type a puppy. Thanks. Amaya, Nick, do you guys agree, disagree? Are you here to comply? Or are you totally lost? Nick agrees. Amaya? Amia? No? Okay. All right. They are indeed opposite reciprocals because one of them is positive. We can see that one of them is positive and one of them is negative. So that's perfect. That's what you need, right? Because this one is, so this one's negative and this one's positive. So that's a good start. And then if you took 5/2 or 2/5 and flipped it, you would get 5/2. So like you just flip it. So they're opposites and reciprocals. So indeed I can put the symbol for perpendicular. So again, that's the upside down T with the square in the corner, or you would just say perpendicular. And I like how Jackson wrote up perp because that's how I had to do it because, typing. All right, let's try another one. Last one of these. And And okay, so let's do y equals 3. No, we already did the 3, huh? Let's do 1/4 x minus 1 and y equals 4x plus 1. Opposite, I mean parallel, perpendicular, or neither? And why do you say neither so fast, Maya? Jackson, what do you say? Nick, what do you say? Neither. Well, 1/4 is a lot smaller than 4. That is very true. But that honestly doesn't have anything to do with, as far as like what we're trying to like. So I guess you can tell that it would not be parallel, right? Because they're not the same slope. In fact, 4 and 1/4, are those reciprocals of each other? Can you flip 4 and make it 1/4? Yeah, so they are reciprocals, but they're just not opposites. It's the same problem that we had at the first one. So, yeah, but one of them needs to be negative, right? One of them needs to be negative for it to be parallel. So if I were to go back in here and draw a negative in there, then we know that they would, like I'm just going to put a negative right here next to the negative one, make it negative 1/4. Then they would be perpendicular. So question, what does the intercept, the y-intercept, like the b on y equals mx plus b, what does that have to do with anything when we're talking about parallel, perpendicular, or neither? Nothing. The only thing that it would do is if you saw two lines and they had the exact same slope, you have to make sure that they are not the same line. And the way that you would do that is just make sure that the intercepts are different. And that's all. So good observation, Jackson. All right. So that is the main idea behind those things. You can find, like if you follow the example that we had right here of plugging a point in, you can do it that way, or you can plug it in this way to find, like if you have a line, you want it to do parallel through that point. But then if you wanted to do one that was perpendicular. So now the next slide here, we're going to do one that is perpendicular. So we're going to go into this, get a big line. So we want, and I just summarize it. We want a line that's perpendicular to y equals 5x plus 1. Oops, I forgot equals 5x plus 1. That goes through point. Let's say negative 15, 3. Okay, we want a line that's perpendicular to that one that goes through that point. So you're going to do it kind of the same way that we did the other way. So let me go through those steps and let me write those steps down because I think those steps are helpful. And the reason why I say it's similar is because it is similar, but it's not the exact same thing. So step 1, and I'm going to put the steps over here. And it's going to hurry and write them up. Step 1, write the equation with the slope needs to have. And what I mean by that is parallel means same slope. Perpendicular means opposite. Reciprocal. So there's our first step. So we're going to come here and we're going to write that equation. So what is the opposite reciprocal of the slope that's right here? What is the opposite reciprocal of 5? It might help if we come back on this other slide and see what we did with 3. 3 we put over 1, and then we flip it, becomes 1 over 3, and then we made it negative. So what is the opposite reciprocal of 5? Yeah, negative 1/5. So hopefully it'll type it nice. So negative 1/5 x plus b. So we write the equation with the slope it needs to have. So we just wrote it like that. Step 2, I'm going to change the color because I can. Step 2 is you're going to plug in the point given. X and the y. Oops, not the 7, it's the y. Okay, plug in the point given for the x and the y. So this, just as a reminder, that this number is the x and this number is the y. So we're going to plug out from the negative 15.3. So when we plug that in, we would get negative 15 equals negative, psych, 3 equals negative 1/5 multiplied by negative 15 plus b. Okay, so do you see how all I did was I put, instead of the x, I put negative 15, and negative, instead of the y, I put 3. Didn't do any fancy calculating stuff. The rest of it is going to be simplify and then solve for b. So the third step, I'm just going to put as one thing together because it makes more sense if it goes together. And that is, so step 3, simplify and solve for b. And then while we're at it, oops, I'm going to put step 4 and plug, oh, that's too many spaces there. So 4, plug the slope, plug b back into the equation from step 1. Okay, so we simplify that stuff. So it's still going to be 3 equals, so negative 1/5 multiplied by negative 15 is just going to be 3 plus b, like that. And then we want to solve for b, so we would subtract 3 from both sides, because I want the b alone. So subtract 3 from this side and subtract 3 from that side, which means that I get, on this one, I get b equals 0. So 0 equals b. Kind of a funny thing. Normally you don't get 0, but then we would plug it back into that original one. So the original one, we had y equals negative 1/5 x plus b, but instead of plus b, we could put plus 0, but I'll put them both here. So we'll do y equals negative 1/5 x, x plus 0, but that's silly to write plus 0, so we're just going to have the actual thing be y equals negative 1/5 x, and that's it. I cut it off, didn't it? Weird. So that is doing the same thing for perpendicular that you did to the parallel, but these steps right here, these 4 steps right here, are the same steps that you can take on the parallel ones also. So write the equation with the slope that it needs, plug in the point for the x and the y, simplify and solve for b, and then plug b back into the equation, which is, I think, the best way to do things. Okay. And everything else, like you might, on a picture, everything else from there, it kind of has to go with that. So if you can remember that parallel means, I can't post these pages, Jackson, I'm going to post something that is much more clear. It will have these steps and it'll be much more clear. It's just that my iPad, which is what I was going to write on, is dead. So I couldn't do it right now, but I will do it and it'll look really pretty. And I'll make a shorter video for it too. But remembering that parallel means the same slope, Perpendicular means opposite reciprocal. The other thing that you might need to remember, do you guys remember in algebra that when you did slope, it was the rise over the run? Because there are some graphs. And if you look at the graph and remember that the rise is like the up and down distance, and then the slope, the run is the horizontal distance between 2 points, that'll help you find it. Another way of doing things is it's the change in the x's over the change. Change in the y's over the change in the x's. Change. The triangle is a symbol for change. Did you guys know that? Delta is what they call it. It's a Greek symbol. Delta y over delta x. And then they also have a specific thing, and you can put like the points in for the x's and the y's, and that's really good in the lesson. But that's what you need to know for the GPE5. Next live lesson, we will do the NCN6. I might just make another separate video that has both of the things in there because they don't take that long, especially if you're not writing with your fingers. So, all right, that's been a long enough lesson. So we will talk to you guys later. You guys have any questions?